Hello students. So today we are going to start a new chapter. The name of this chapter is Combustion and Flame. So this is the chapter in which we are going to discuss about what is combustion, what are the various type of combustion process, what are the conditions required for the combustion, what are the products that can be produced out because of the combustion, and we will discuss about the flame, type of flame and their structure of flame. And yes, we will discuss about how we can extinguish the fire, where various options we are having. So moving ahead, so what is this combustion? So you have seen this process of burning. This is very common when we are going to burn any substance like wood, like paper, like any fuel, like kerosene, like LPG. So you are going to watch this kind of process. So combustion is a process. So, as per the definition, the process of burning of substances in air or oxygen with the evolution of heat and light is known as combustion. So, the process of combustion is basically taking place in the presence of oxygen. And yes, whenever this combustion process will take place, so there will be a evolution of heat and light. So, this is called as combustion. Remember, combustion is a chemical process. So we can say that this combustion is a chemical reaction basically in which heat and light is going to produce, and there are some other products also which are going to be produced because of combustion. Now, moving ahead, so let us discuss about this topic, that is combustible and non-combustible substances. So remember, combustible substances are those substances which can burn easily in the presence of oxygen to produce heat and light, whereas non-combustible substances are those which cannot burn easily or which do not burn easily basically. So these are non-combustible substances. So if you can see, the example of combustible substances are like paper, like wood, like LPG. So these are the common example of the combustible substances, whereas if you can see the non-combustible substances, so the examples are like stone, like metal. So they are not going to burn easily. If we are going to try to burn it, so they are not going to burn. So that is what a non-combustible substance is about. Okay, moving ahead, so when we do this process of combustion, so when we do this reaction to take place, so there are many products that are going to produce out. So I have already told you, like heat and light will produce. So remember one thing, when we are going to combust any substances like fuel, so fuels are mainly composite, the composition of fuels are having hydrogen. So this is the element which is present in this fuel at most, hydrogen and carbon. These are the two main elements which are present in the fuel. So together we call it hydrocarbon. So when we are going to burn this hydrocarbon as fuel, so there are many products that are going to produce when we are going to burn it in the presence of oxygen. So one thing is this, and yes, the products are like carbon dioxide, which is going to produce, and the water, which is also going to produce. So remember, heat and light will also produce because of combustion, and carbon dioxide and water, these are the two main products which are going to produce when we do the combustion. Okay, one more thing is that when we do the combustion, to have this combustion completely, so we have to give the complete and full supply of oxygen. So oxygen is basically a type of chemical, or you can say element, which help in the process of combustion. So it is a kind of supporter of combustion. So let us see this particular reaction. So here we are having the example of complete combustion. So in this we are having the hydrocarbon. This is the simplest hydrocarbon. C is carbon, H is hydrogen. So it is CH4, that is known as methane. So methane is the simplest form of hydrocarbon and it is available in the gaseous form. So when we are going to burn it in the presence of oxygen, which is a supporter, O2 is oxygen. So in this when we are going to do this reaction, so what will happen, it is going to produce two main products, that is carbon dioxide and this H2O, that is water. So this two main products are going to produce, and yes, there will be a large amount of heat or large amount of energy that is going to be released in this particular combustion process. So this is the complete combustion, when there is a complete supply, total supply or full supply of oxygen. So combustion can take place when there is a limited supply of oxygen, that is incomplete combustion. So that combustion is basically incomplete combustion, where supply of oxygen is very limited, it is almost not available. So that time methane is going to combine with the oxygen which is available in limited amount. So they are going to combine together to form a product that is carbon monoxide. Remember, this is carbon monoxide, earlier it was carbon dioxide. So carbon monoxide is going to produce when there is an incomplete combustion, and yes, water will come out, and yes, energy will also be produced, but this energy is very less in amount as compared to the complete combustion. So complete combustion is favorable, I mean it is favored basically, but if oxygen is not available, then naturally the process will incline toward the production of toward the emission of carbon monoxide. So this is going to happen when there is a incomplete combustion. Okay, now moving ahead a little bit, discussing about this carbon monoxide. So remember, carbon monoxide, which is basically represented as CO. So this is the short symbol of carbon monoxide, single carbon and single oxygen. So remember, this carbon monoxide is a gas, and this gas is very toxic in nature. And one more thing is that this carbon monoxide is colorless gas, so it is not visible basically. And yes, it produces when there is an incomplete combustion, so that this gas is going to produce. And one more thing is about this carbon monoxide, as I have already told you, this is a toxic gas. And when this gas is available, so remember, this gas is going to produce when there is insufficient amount of oxygen. Sometime when we burn something like wood or coal inside the room which is closed, so that time chances are there, confirmed chances are there, that carbon monoxide is going to produce. And remember, there is no odor, no color of this gas, so you never know when this gas is going to come out. So what will happen if this carbon monoxide is going to produce inside any chamber or inside any closed room? So this carbon monoxide is going to combine with our pigment which is present in our blood, and that pigment you know very well, that is hemoglobin. So this carbon monoxide is going to form a complex with this hemoglobin that is known as carboxyhemoglobin. And remember, this carboxyhemoglobin is a toxic complex. So basically, if I am going to tell you about carboxy or carbon monoxide, so carbon monoxide is having more affinity toward hemoglobin than the oxygen. So what I mean to say, if carbon monoxide and oxygen both are available in our atmosphere, so our blood, that is hemoglobin pigment, is going to attach the carbon monoxide more quickly as compared to the oxygen. The affinity of carbon monoxide and this hemoglobin is 8 times more than the oxygen. So that means naturally what will happen, carboxyhemoglobin is going to form, and this complex is going to affect our brain, that is our central nervous system. So it is going to affect the function of brain, and the person who is going to inhale this carbon monoxide in a large amount, so first of all he is going to unconscious, he is going to become unconscious, and then after that he is going to die. So that of person is 100% sure because of this carboxyhemoglobin complex. So that is because of carbon monoxide that is going to produce when there is incomplete combustion. Okay, now moving ahead with the condition which are necessary for the combustion. So let me tell you about the condition. So before that, we can observe this activity. So this is the simple activity you can perform in your home also, but you have to be very careful. So what you have to do is you have to take a candle and just burn it. And after some time, what you have to do is put a glass that is a kind of glass which is available in your kitchen, and put it onto in inverted form, like this, as you can see in this picture. So this inverted glass can be placed over in this onto this burning candle. So what will happen after some time, you will see after 5 or 6 seconds, what you will see is the candle, this flame of this candle will blown away. That means this candle stop burning basically. So why it happens? It happens because of the air which is available inside the chamber, this glass, will be used up by the combustion process, and whatever amount of oxygen that was present inside the this glass chamber will be utilized by this combustion process. And so what we can conclude from this particular observation, that oxygen is necessary. That means oxygen, which is a supporter of combustion, is necessary for this process of combustion. And when we are having limited or almost negligible amount of oxygen, so this flame is going to be blown away. So this is the main observation. And yes, for the combustion, remember there are two other conditions which are required. First thing is the oxygen. Second condition which is required, obviously, there must be combustible substance. So if there is no combustible substance, then the combustion will not take place. Like in the case of stone and metal, we have already seen in the first slide that if this kind of non-combustible substances are present, then the burning will not take place or the combustion will not take place. So combustible substance here in this candle, that is wax, is present, so this combustion will take place. And third important thing, third condition that is required for the combustion is the ignition temperature. That means a combustible substance has to be heated to its ignition temperature, and because of that only the combustible substance is going to burn. Now, what is this ignition temperature? Let us discuss little bit in detail. So the question is straight away, that is, what is ignition temperature? So the clear-cut definition of ignition temperature is, just look at this definition. So it is the lowest temperature at which combustible substances start burning. That means it is the lowest temperature at which the substances start burning in the presence of air, obviously in the presence of air. So that temperature is basically called as ignition temperature. Remember, all the combustible substances have different ignition temperatures. Like wood is having different temperature, paper is having different temperature, petrol is having different temperature. So they are all having specific and particular and different ignition temperature. So let us discuss this. Let us see this image also. So if you are going to try to burn this wood with the help of mastic, so you will find that with the help of mastic it is not that much easy to burn a piece of wood, whereas same mastic can burn the LPG gas stove. Like this, you can see this flame is coming out. So single mastic is sufficient to burn the fuel, that is the LPG. So what we can conclude is LPG ignite very quickly as compared to the wood. Why? Because the ignition temperature of LPG is very low as compared to the wood. So single mastic is sufficient to burn the LPG, whereas this burning mastic is not sufficient to ignite the wood. So what I mean to say, what this ignition temperature is all about, that means LPG is having low ignition temperature. And what we can also conclude is that LPG is highly inflammable. That means the combustible substance or fuel which is having low ignition temperature as compared to the others, they are called as inflammable, highly inflammable. They can burn very, very easy. So there are some other fuels also, like alcohol, like kerosene, like petrol. They can also burn very easily. That is why highly inflammable word is basically used to describe their characteristic. Okay, now we can have one more question about this ignition temperature. So you have observed that why does a mastic do not catches fire on its own? So you have seen mastic. So mastic is used to produce the fire, but the thing is this mastic is not going to burn by its own. Why? The question is there. So the answer will be, this is because mastics are at the room temperature. So we are going to place the mastics at the room temperature, and yes, the ignition temperature of these mastics are much higher. So what we can say, yes, so this ignition temperature of these mastics are higher. So yes, so when we are going to rub the mastic on the rough side of the matchbox, so heat is going to produce. So by producing the heat by the help of friction, so this is going to increase the temperature of the mastic. And yes, the temperature of ignition, the ignition temperature will be achieved by this rubbing or this friction process. So that means when we are going to rub the mastic like this, so the mastic will burn or it will ignite. So like this. So that is why generally the mastic do not catch fire on its own. It has to be rubbed onto the rough surface like this in this particular clip. Now moving ahead, there is one more question. Why does a paper cup with water in it does not burn when held above the candle flame? So remember, paper cup, or sometime we can use filter paper filled with water. So in this particular clip you can see So we are having in this side, right side, we can see this is the filter paper, which is simple dry filter paper, and you can use the paper cup also. And here also this is the type of filter paper which we have used, conical shape filter paper. It is like a paper cup only, in which water is filled. So if you are going to put these filter paper like on this side, so this is going to burn quickly, this particular filter paper or paper cup. Whereas here where water is there, so this is not going to burn easily. Why? Yes, again the answer is because the dry paper cup is having low ignition temperature, whereas the wet paper cup is having high ignition temperature. So, and one more thing which is going to be held over here is that the water is in this situation is taking the heat from the flame of the candle, and I mean this paper cup is not getting direct heat. So whatever heat is given to this paper cup is basically conducted to the water. So ultimately this paper cup will not burn, and yes, the temperature of water will keep on rising in this particular activity. If you are going to observe this activity, so you will find this kind of thing, that the water temperature will raised, and yes, why it will be raised? Because it will get the heat from this paper cup, and yes, paper cup will not burn easily. This is the case. So hence it is written over here, hence it is its temperature does not rise above its ignition temperature. That is why this paper cup which is having water will not going to burn easily. Now moving ahead with the next topic, that is about the type of combustions which we can have. Yes, so combustion are basically divided into three types. One is known as rapid combustion. So what is rapid combustion? So combustion in which a substance burn quickly to produce heat and delight, and that is called rapid combustion. And yes, burning of LPG, you have seen in your kitchen, burning of LPG stove, LPG gas, that is going to combust very rapidly. Burning of mastic, these are the type of combustion which take place very quickly. So that is why it is called as rapid combustion. And second is the spontaneous combustion. Spontaneous combustion in which a substance burn into flame without the application of heat. That means the substance burn on its own without the application of heat. So that is spontaneous combustion. And the example of this type of spontaneous combustion is basically white phosphorus. You know, white phosphorus is a chemical. Maybe you have heard in this metal and non-metal chapter. So we have to keep this phosphorus into the water. Otherwise, what will happen? Yes, this white phosphorus will burn. So it will burn spontaneously. So that combustion is basically known as spontaneous combustion. Okay, the third type of combustion is known as explosive combustion. So explosive combustion is also very sudden process, and no doubt in this particular combustion large amount of heat and gas is going to release. So this is a kind of explosion. So burning of firecracker is the example of this explosion or explosive combustion. So this is all about the type of combustion. Now moving ahead with the important topic of this combustion part is the extinguishing a fire. So extinguishing a fire. So remember, fire, uncontrolled fire can be disastrous. So it is necessary to extinguish fire before any loss. So this is very important thing, that how we can control the this fire. Otherwise, if we are not going to control it, so the disaster, it could be disastrous, and the consequences of this fire can be very fatal also. Okay, now the thing is, you know very well, the fire or the combustion process will take place because of the conditions like presence of oxygen, presence of combustible substances, and heating above the ignition temperature. So these are the conditions which should be there for the fire or for the combustion. So how we are going to control this fire? So normally fire can be controlled or extinguished with the help of water, but this water cannot be it cannot be fulfilled for all type of fires. So some fires are there where water cannot be used. So basically there are some methods in which how we are going to control this fire or extinguish this fire. So the condition required for this extinction of fire is removing the combustible substance. So the first option, that is we can remove the combustible substances so that fire can be controlled, but it is not easy, and this task is very difficult because when there is a fire in entire building, so we cannot remove the combustible substance so that time, so it is not possible. So the second approach or second method that can be involved is the cooling the substance below the ignition temperature with the help of water. So to control the fire, what we can do is we can spray the water so that the temperature of the burning substance can be lower down and below its ignition temperature, and that is how we can control the fire. But the thing is, in case of fire, because of fire in electrical equipment, we cannot spray water directly onto it. Otherwise, what will happen, you know very well, water is good conductor of electricity and it can cause electric shock also. So that is why we cannot spray water onto the fire because of electrical short circuits. Similarly, fire in oil or petrol cannot be controlled by the waters, because you know very well oil is lighter in weight and it basically float onto the surface of water. So when we are going to put water onto the fire, which is because of the burning of petrol or oil, so that oil is going to keep on burning. There will be no effect of water. Maybe it will increase the impact of fire. So how we are going to extinguish fire, that is the question. So now the third method which we can apply is cutting off the supply of air. So better is to reduce the, just cut off the supply of oxygen. So that can be done with the help of carbon dioxide gas. You know very well, carbon dioxide gas is the gas which basically do not allow the combustion, just opposite to the oxygen. So what we can do, we can apply the carbon dioxide gas, and yes, carbon dioxide is heavier gas, so it forms a blanket around the fire, and it does not allow the passing of oxygen to the fire. And yes, after few seconds the fire will be turned off because of the insufficient amount of oxygen. So this can be done. And yes, for this process we can have fire extinguishers which is available in market also, which give off carbon dioxide, and it can be used to for this particular purposes. So this is the clip which is showing you how these fire extinguishers are being used to control the fire. And yes, there are many type of fire extinguishers. As per your syllabus, we are having the common type of fire extinguisher which we are going to study in detail. That is the soda acid type fire extinguisher. Remember, this is soda acid type fire extinguisher, in which we are using two type of chemical to produce the carbon dioxide. One chemical is the sodium bicarbonate, which is soda, and yes, the second is the acid, that is sulfuric acid. And yes, when these both chemicals are going to combine together, so they are going to release the carbon dioxide gas. Now carbon dioxide gas, if you can see this chemical reaction, so here you can see sodium bicarbonate and sulfuric acid both are going to combine together to form sodium sulfate and water, and carbon dioxide gas is going to release. So this is the chemical reaction which take place inside this particular fire extinguisher. Now if you can see this particular structure of this fire extinguisher, so here you can see this is the bottle or can like structure or container in which sodium bicarbonate solution is present. And in this particular bottle, you can see this is the glass bottle in which sulfuric acid is present. So this is the glass bottle in which sulfuric acid is present, and this is the container in which sodium bicarbonate solution is present. And this is the knob. So these are the three main structure: knob, bottle and container, in which this acid bottle is having acid and container is having sodium bicarbonate. So when we push this knob, or when we open this knob, so this bottle break down, and this acid split onto this particular sodium bicarbonate solution, and the reaction will take place like this reaction. Sodium sulfate plus water is going to release, and carbon dioxide will rush out through this particular hose pipe. This hose pipe is connected, so we can use this pipe to spray the CO2 onto the burning site. And yes, we are having some other type of fire extinguishers also, like foam fire extinguisher is also available in market, and dry powder fire extinguisher is also available in market. So these kind of extinguishers are basically used for specific type of fires, like if solid or liquid kind of substances are burning, so we can use foam fire extinguisher. And when liquid is burning, basically like of electrical wires are there which are burning, so we can use dry powder fire extinguisher. So the chemical is basically different in these type of fire extinguishers. Okay, so this is all about the fire extinguisher. In the next video we are going to discuss about the flame and its structure in detail, and yes, we are going to discuss about the environmental impact of the burning process also.